All right. I hope everyone's doing doing good today, staying safe. Today, I do want to talk about how we can, we've kind of shifted from an older delivery model into the newer, at least hopefully, we're on that journey into a newer software delivery model. And there are some caveats to that. So we'll get into that in a second. First, I'm Kevin Cochran, solutions engineer, been here for about a year and a half, and learned quite a bit about how infrastructure as code can really transform an organization. And hopefully I can impart some of that to you. So first off, let's just kind of talk about where things were, so I can give some context, what we needed, what we realized we needed to change, and how we're getting there. So let's go ahead and start. Just look at how we did things before. So what we used to do, and some of you still may do this, is we have dedicated infrastructure, maybe purpose built. So we had it for specific types of applications. And a lot of these have been around for quite some time. And what happens is you start off with one configuration, and then 3, 4, 5 years later, it's nowhere near what it started was, and certainly the documentation hasn't been updated any time in that in that time frame. So there's some problems we come up against. First, it's a very manual process. It's to stand up a new server, to configure the hardware, bring it into your virtualized environment, stand up a VM inside that, configure the OS. You've got burn-in policies. On average, it could take anywhere from 3 to 6 months for a brand new server to be delivered and ready to use. And because of that, we cram as many applications as we can onto the same box so that we don't have to request more hardware or another VM, because that might not be available. So the problem here is that if one application spins out of control, hogs all the resources, whatever, something happens to it, a lot of the other applications become a casualty to that one. And that is definitely a very real problem I've seen. And so we know that even our new servers are already 3 to 6 months old. What about the existing ones that can be several years old, some even longer than that? And that does put our applications at risk as well, because after time the hardware is it's not as stable. So when it came time to deploy an application, it was very manual. And I mean manual, like literally copying and pasting a bunch of files from your pre-prod environment over to production. And of course, if it's a brand new app, you have to wait for the server to be configured, the web server, whatever. So again, very manual. But one really, really good thing about this is that the people who understood the infrastructure the best were the ones who had access to it and were the ones who were making the changes. You didn't have developers going into the network and making network changes. It was our network people who know that that's their job, and that's what they studied in, and they're really good at it. So everything was deployed safely. But application delivery was very, very slow. Companies who were rolling out changes even a little bit faster, they were making more money. Even if we're talking about just shaving off a couple of weeks, customers would notice. I know I noticed when this transition started happening. I started seeing changes in the software that I was using, and I thought it was pretty cool. But we need, we as developers, or we as an IT organization, needed to figure out a way to get our new features and enhancements out to our customers more rapidly, because we saw some real benefit there. So instead of having all of our teams try to deploy a massive monolithic application, which has a lot of dependencies, everything's coupled together. So we decided we would decouple all that and take the microservice approach. So it was a whole lot easier to code, to build, to test, and deploy. Much smaller blast radius, all that kind of stuff. Made everything a lot easier. That's what we're hoping for. That's what a lot of us have achieved. We also found that with the advent of public cloud providers and them gaining so much popularity, we could actually bundle our infrastructure along with our application. So you could actually pre-package the whole thing. So any kind of infrastructure dependencies could go along with it. Well, patterns for software distribution, I think, stayed in flux for several years. Some may argue and say it's still in flux, but at least today we have container orchestration, which has helped us make sense of what containerized workloads should look like. But now then we had new problems, and what that meant for us is that all this new technology, the new way of doing things, did not fit into the old way of doing things. It just didn't. You know, we tried to make adapters, tried to make fittings, however you want to think about it, but it just didn't fit. And we weren't going to go back because we could tie that directly, the new stuff directly to revenue. So we didn't want to go back. So it was time to make a change in how we delivered our software. But we needed to do so safely. So some software like Jenkins, one of the early ones that kind of repurposed what they already had, this kind of step-by-step build process into more of a staged kind of process where a developer could easily automate the entire process, which eventually were called pipelines, and many others have come along since. But we call them pipelines mostly because the tool chain is fairly complex, especially today with advanced testing and code quality checks, integration tests, security tests, so on and so forth. But really, our main goal with all of this was to remove the human element so we could truly automate end to end. And we were mostly successful, but we weren't quite there. There was still this one little piece, and that was that the app's resources, that provisioning step, whatever code we were using, now that we're at least doing infrastructure as code, that code still needed to be reviewed by an infrastructure team because they wanted to make sure that whatever we're provisioning didn't put our environments at risk. So with all the efficiencies that we gained with everything else, we still could be waiting, several days or several weeks until that step was done. So enter Terraform, what I would coin as the savior of provisioning. It really doesn't take a whole lot of time to understand the benefits of provisioning with Terraform. It's pretty straightforward. First off, it gives us one common language across all clouds, all platforms. And this HashiCorp configuration language, it was actually designed specifically for provisioning, as opposed to, say, writing things in JSON or YAML. It's not really infrastructure as code in my view. It's more like infrastructure as data, because you're not really adding functions in there. I know that some of the cloud providers do have kind of odd ways of doing functions, but we have a dedicated language for provisioning with Terraform. So actually running Terraform is super simple to use. I mean, the concepts are very, very basic. So you get a dry run with a plan. You can do a create or an update with running an apply. You can tear it all down with a destroy command. And since everyone can work out of the same repository, it really makes it easy to work with teams, work very well with teams. And you also have the ability to automate your entire pipeline end to end. And I actually selected the word ability very specifically because we're able to automate doesn't mean that we actually get to automate. So infrastructure teams and security teams aren't going to let us do whatever we want to do. Traditionally, security teams and development teams haven't really ever needed to collaborate. It's just kind of, you put in a ticket and you send it on and ask what you want. But devs kind of want to open up things that they shouldn't, and security wants to lock everything down. And so there's this kind of tug of war, but we want to get them to a point where they're working better together. In addition, with DevSecOps now being a requirement in most organizations, security already manages part of the pipeline with code reviews, or at least security teams. In some organizations, security teams own that part. And then, of course, we have those beloved infrastructure code reviews. And I do have to tell you, as much as developers don't like having to, push that over to be reviewed and wait on that, security folks don't like to review them either. I mean, it's just a necessary evil. But the whole point is that all of us are humans, whether we're developers or security, and things can still get missed just with eyeballing things. So now we have all these great tools at our fingertips, and we still can't fully automate. So this is what I'm getting at. We really need some way to ensure that developers are not only following the rules, but we need some way to scan their infrastructure code, Terraform code in this case, to identify any other types of compliance violations. So with Terraform Cloud, it comes with Sentinel, and Terraform Enterprise, Terraform Cloud come with Sentinel, which is policy as code, and it can guarantee policy enforcement, meaning when I use the word guarantee, meaning you can't have someone inadvertently switch it off or bypass it in your build pipeline. It has to be run. Also, Cloud comes with Terraform Cloud and Enterprise both come with the private module registry. So these are basically kind of reusable snippets of Terraform code that infrastructure teams can build and put out there for development teams to consume and use in their own code. So you can kind of make sure that there's some consistency and safety in your organization. And if you're trying to get a handle on your cloud spend, wouldn't it be a whole lot better to get in front of that rather than get the bill and you still have to pay it anyway? You might be like, oh man, I can't get a refund on this because you've already spent it. It's consumption based. So, instead of paying the bill after the fact and then trying to fix it, why don't we get ahead of it and say, let's put some spend limits on these workspaces. And of course, everything in Terraform Enterprise, all these functionalities are accessible by the API. So, and we're gonna see a little bit more of that here in just a minute. I've only got a couple more slides, and we'll jump right into the demo. So Sentinel is the piece that allows you to both automate and ensure compliance, or enforce compliance, I should say. So admins can create a whole host of policies which can act as guardrails. Sentinel runs right before the apply does, so any violations can be caught and you can stop the run before the apply actually happens. Infrastructure teams, security teams can control what policies are attached to which workspaces, so you have a lot of flexibility and basically giving them full control over what is allowed to be provisioned. And given the guardrails, it actually unblocks engineering teams. When you give them a set of rules and then you have a way to enforce those rules, you don't really have to be involved in their process. You don't have to do code reviews. I mean, I guess you can if you want to, but the point here is that you have the ability with Sentinel to automate. And of course, this allows you to deliver your software a whole lot faster and a lot more efficiently. Just kind of a real quick example of this is what we have on the screen here. Let's just say we have 3 modules. We've got a VPC, we've got a security group, and we've got a subnet module. So now we can tell all of our engineering teams, or some of our engineering teams, that if they use these 3 modules and they don't try to create any kind of networking resources, then they can go to production without a code review. Because we've kind of blocked them in. This is a very simple example, but you really kind of block development teams into what they can and can't provision. So, but at least with this, we say, you know what, you follow these rules, you can go to production without a code review. So during the run, Sentinel will find out if they actually used all 3 of those modules. If they did, then great. And it'll also find out if they try to create some of their own, like if they try to create a security group to open up a port 8080 and that's not really allowed. Well, guess what? You can stop that as well. So we're basically just giving them the room that they can move in without unleashing engineering teams to be able to do whatever they want. Sentinel can do a whole lot of things, and by the way, these are some of these modules are actually readily available out there as far as Sentinel code modules that are out there. So a lot of fun stuff that we have available. But so yeah, some of the things that you can do requiring modules, you can get out in front of your cloud spend, like I mentioned, no custom networking resources, things like that. You can require tags, you can restrict availability zones or instance sizes or VM sizes, just a whole bunch of things that you can do. I mean, basically, basically what you're looking at with Sentinel is Sentinel has access to everything in a particular workspace that's already been created. So if you come in to do an update or a remove or an add or whatever, and then it also has access to everything that you're trying to apply. So all of that data you can act on with Sentinel. Even if you need external data, you can make an HTTP call and get some external data if you need to. So a lot of powerful features in Sentinel. And now we are at the point where we can do a quick live demo. It's not super quick, but let me go ahead and, okay. So I'm going to show you exactly, hopefully I was clear enough in what I was talking about, but I'm going to actually show you exactly what I'm talking about. So as I mentioned, when you deploy your infrastructure, just to kind of hone in on this one thing, that we have the ability today to automate everything, including infrastructure, but the security part needs to be owned outside of the development teams. It just needs to be outside of that. The interests are different, the expertise is different, and so we want to keep it that way, because you can't be an expert of everything, plus separation of duties, a lot of reasons why. And so what we're doing is we're now giving, with Sentinel, we're giving that ability to complete the automation piece by letting other teams participate in the pipeline. So that's the bottom line of what we're looking at today. So here we have a Jenkins build. I used to work in Jenkins. I'm not a total Jenkins pro, but in my previous life as a developer, this is what I used. And this repository, I have a repository where you can build this entire simulation out for yourself, and we will include that repository in a follow-up email. So if you want to get in there and play around with this, you can. So here's a pipeline, and I'll just kind of show you. We'll just take a real quick look. You know, this is just pipeline code. It's written in Groovy, so we've got a whole bunch of big old long script here. Not super fun to look at, but I've got some code snippets that we can look at and kind of zoom in on as we move along this. So what we're doing here is we're just going to go ahead and clone the repository. This is very simple. So I didn't do all the complex, like, you know, code analysis and all that stuff. All we're doing is we're going to clone the repository. We're going to build a Java application. We're going to upload it to S3, and then we're going to provision an EC2 instance. So what we're, and the purpose here is that we're actually going to drive all this. This is going to be completely UI driven. I'm going to show you what's happening in Terraform Cloud and what's happening with Sentinel and all that stuff. But either way, we're not doing command line. This is kind of nice, where we can just turn these pipelines over to a developer. They can run it, and we'll see what happens. There's a couple of different modes with Sentinel that you can either do a hard mandatory, where it just stops the run dead if it finds a violation because it's been marked as hard mandatory, where that you don't pass go, you don't collect $200. You just it stops. You need to go back and fix it before you can continue. There's also a soft mandatory, which allows you to override. And so I want to show you kind of what these policies look like. So in this particular one, I've got 3 different policies. I'm not using the required modules in this particular one just because it doesn't use a module. But we have, this is Sentinel. This is actually Sentinel code. It is a policy language, code language. So what we're doing is we're saying we're making sure that we're using the proper sized instances out in AWS. So we've got these 4 we can use, T3 micro, all the way through T3 large. And so long as we're using that, then we're fine. Sentinel, this is how we specify them. So using the proper instance is a hard mandatory. So it will stop me, and I won't be able to do apply it until I fix that myself. Limit cost, that's a soft mandatory. And for this particular one, if you think about it, if you put $100 limit monthly spend on a workspace, and you do the run and it comes up to $101, you're like, hey, I can't really shave off $1 anywhere. That's not really a way to do that. So instead of going through and reconfiguring the workspace, instead, you can just say, you know what, I'll just allow this to be overridden. And so somebody can come in and they can override that. And we're going to see this in action today, and as it's being driven through the API. So let's go ahead and get started. I'm gonna come down here and kind of get a few things ready for you. But I'm gonna go ahead and hit build, and we're going to see it kind of go through here. These first few steps don't take too long at all. But then I'm going to have you come over here and take a look at Terraform once once we get to that spot, and we'll see in the UI, in the Terraform UI, that it's actually corresponding very well with what's going on in our Jenkins build. So here we go. I'm just going to refresh. And as you can see, I didn't do anything in here, but it does say it triggered the run from Jenkins build number 12. So let's go in here and see what happened. Okay, so we've gone through, we're looking at the plan. It's just about to complete the plan. Move on to cost estimation. And then after that, we're gonna do the policy check. Okay, so we take a look over here, and if you see, we now have a dotted outline on here, which means that it's time we need somebody to take a look at this. Let's look at this policy over here, and I can pull all this message into Jenkins if I really wanted to. There's a whole lot of things that you can do, the art of the possibles there, but it's telling me that this is $60. You know, my limit's actually 10. So me as the supervisor or manager or whatever would need to come in and make that decision to override. So I can come in and I can say, you know what, actually I'm not going to override this. I think that's just way too much. So there we go. It just failed my build and it actually aborted over here. The apply will not run. So again, I beg and I plead my case and I finally get approval. So now I'm going to kick off a build again, and we're going to go through the exact same thing. And should be applying right about now. We're running. So you just saw this. You can see it's build number 13. It's just send that over in the API. And while that's planning, what we're doing is we're coming through and we're just simply using like a start the plan here. So I'm going to kick off the run, and this is in Groovy again. You can do but what I'm wanting to point out here is all I'm doing is an HTTP request, and I'm sending over a payload. Now let me show you what that payload looks like. So I'm just sending over a payload, a JSON payload that says, hey, here's my workspace. It's triggered from Jenkins, and there we go. So if we come back over to our Terraform, again, we have the same failure. But now, since we're driving everything through Jenkins, I can come over and, as the manager, like, okay, fine, we'll let you do it this one time. So now I can continue. And if you come over here, this is going to change right before our very eyes. Isn't that magic? To confirm. So this needs confirmation. I can configure this workspace to auto apply if I want to, and that's where we can really automate things. Just for the sake of coolness on what we can do with the API, I left it in here. So again, now the boss man says I can go ahead and implement this. Now I'm going to go ahead and apply. I could still abort, and it would fail again, and I have to go through the whole process. But no, I'm going to go ahead and kick it over. And so we should see, there we go. So now it's actually going to apply. And we can go into our console, AWS. And once it's done, we should see my instance in here. Once it's complete, let's go back over here. Okay, so it's creating, just finished creating it. Let's go ahead and do a refresh. Or maybe, hold on, let me see what I named it. Let's refresh, I think I named it something different, yeah. Let's see, simple. There it is, Kevin, oh, it's just Kevin. Kevin Simple Server. So this is the one that I just spun up, and it's now running. So, and that's corresponding with my Terraform Simple instance there. So pretty simple, pretty easy. Just to take a look again, kind of zoom in on some of this code of what we actually ran through on here. So first thing that you need to do when you interact with Terraform is you need to get the workspace ID. Of course, you'll need a bearer token, and the token you can get in the UI. It's just under your own profile. You can create tokens for users, for teams, or for the entire organization. But that's just the API token that you would use when it's like you're interacting with any kind of SaaS software. So that's the token. But we want to get the workspace ID without having to actually go into the UI and copy and pasting. Let's go back over here and I can show you the workspace ID right here. I mean, it's not really pretty to look at. It's not easy to you're not going to memorize that. But I do know Terraform Simple Instance. That's my workspace name. So instead, what I'm going to come over here and do is I'm going to get the workspace ID for the application to use, but I'm just going to use my workspace name because that's what I want to do. So I send over the organization, the workspace name, and I get that ID back. So next, I think I just showed you this a minute ago, but here's the payload that we're going to send over. We're going to send over the workspace ID right here, and I just used a here doc to plug that in there. Next, we're going to kick off a plan, and all this is documented on our website. So we're going to go ahead and kick off a plan with that payload and get an ID back for the run. So we do want to get that run information because that's how we're going to poll. So, and by the way, this ID right here is what we want to get back. The plan, now we need to poll the plan. There's a whole bunch of statuses out here. But this is just kind of an example, but we want to poll it, and we can do so by, again, hitting the runs and then just giving the run ID that we received from the last call that we did. And I'm looking for something very specific in this one. I've got several other statuses in the real one. You can look at it if you so desire, but I'm looking for the policy override so that I can, if something is needing some input, I can actually drive that through Jenkins instead of making somebody log into the Terraform UI. So that way you have a single tool to work out of instead of a whole bunch of different screens. But I need to get that policy check ID out of there, and that's why I need to do that. So I'm going to send the result over, and what we're going to do is we're going to override that policy by hitting the policy checks and actions and override endpoint in Terraform Enterprise. So these are, again, we're still just using the same, bearer token, things like that. Everything's very straightforward. We try not to make real complex API calls, just kind of bare bones, basic, what's needed. It's, I can't remember the term we use, but it's sensibly opinionated, I think is the term that we use, something along those lines. But once we get back confirmation that we're ready to go, then we can actually, again, hit the runs endpoint with the action of apply right here. And we send it the run ID, and that's kind of how all that worked. I know it's a little bit of code, and hopefully there's enough of you out there who like to geek out on that, but once again, this code is available in the repository, and that we'll be sending out later. It's this one right here, my Terraform Jenkins pipeline. So, but that really kind of concludes the demo. Hopefully this was useful, and you can see, and hopefully this actually could potentially unblock some of your teams being able to fully automate and do so securely. And with that,
that's great.
Allison, I'll turn it back to you.
Cool. Yeah, we have a few questions to go through, so I'll read them out for you. First, does Sentinel have the ability to perform any sort of static analysis of configuration, or do you only have the option to enforce at plan apply time?
You only have the ability to, well, okay, let's back up. There is a Sentinel CLI, which allows you to go through and test and make sure that whatever it is that you're doing is actually going to work. Let me share my browser with you again, and I'll point that out. Here it is. let's go back in here. So from this particular run, I can take a look at right here, and I can download Sentinel mocks, which I can use with the Sentinel CLI to validate that my policies actually work. So let's go over to like testing your policies. And we may want to include this in a follow-up just for anyone who's interested, but we have a whole article on how you can test your Sentinel policies. So yeah, if that's what, hopefully that's, I understood what you were asking for. You know, certainly it's not going to give you a score as far as like, you know, if your code was pretty or you had too many comments or you commented out code, it's not going to give you that level, but it will definitely at least give you the unit tests. If that's, you know, if you need to drill down in that, then please throw another question in there, and I'd be happy to kind of drill back in on that.
Sure. We had another one come up. Can you update the Sentinel policies via API?
Yes, you can. Let's see if we can find that one. Let's see. It's usually through the admin API docs. So let's take a look here. It's not at my fingertips like it normally is. So why don't I follow up just in case I misspoke? We'll take that as a follow-up item. Let me take a note real quick and see if we can do that. I am pretty sure, but I want to make sure that I give you 100% accurate information. So we'll just take a note real quick and follow up.
Okay, how does the workflow differ between self-hosted Terraform Enterprise and Terraform Cloud?
The workflow doesn't change. Sentinel, you don't need some of the extra features that Terraform Enterprise has, such as single sign-on and you know, other features, audit logging. You can still use this exact same workflow, whether you're in In fact, everything you saw today is actually in Terraform Cloud. So there you go.
Great. And then is it possible to write Sentinel policies that only apply to specific team members and not others?
No, Sentinel is workspace based. So it's either all workspaces across the board, or you can select which workspaces are targeted. So let me just show you what I'm talking about. Let me get back over here to share. So if we come in here to settings and we take a look at our policy sets, you know, I've got several in here. So let's just say we'll take this one. I can either apply it organization-wide, or I can select which workspaces. So if I just say, you know what, I'm going to get rid of that one, no workspaces applied right here, I can say policy enforcement on all workspaces. So these are handy when it comes to making sure that, you know, security groups, you know, there's no CIDR blocks that are open to the whole world, things like that, that are just, you know, they're no-goes for any organization. So just across the board, we're going to do that. Whereas these might be like, you know, certain teams have certain cost limits, or they have various other restrictions for, you know, like maybe one team can use RDS and another team can't. And so that's when you would simply pick that, add the workspace. I can add more if I want, and so on and so forth. So I can update the policy set and all squared away. So it's really flexible. I just can't apply to users and teams. However, one caveat on that is that, you know, your users and teams can be assigned to specific workspaces. And so in that manner, you can control it. It's just not a direct control.
Gotcha. Okay, last few. When one workspace has a dependency on another, does Terraform automatically update the workspace that has the dependency?
No, the workspaces are independent, and they always will be independent. There's some other, you know, there's always ongoing work in terms of that, but of what we're doing with workspaces and how you can manage them. But workspaces just kind of by nature, they really are kind of independent pieces of code. I think some things that are coming out in the future, being able to chain some of the workspaces so that, you know, when we do have some things that kick off, you know, that are dependent on other ones, but it doesn't actually change any other code in any other repository. So that code must be maintained by whoever maintains it. And the reason for that is just to make sure that your Terraform code is not just, you know, the code to build out the infrastructure. It's also your documentation. It's also your source of truth. And so that's why we don't have an automated way to just, you know, upstream change either, you know, the code itself or even workspace settings. However, you can do that through the API. If you have a use case for that, you can use the API to make workspace changes, or obviously, you know, with code, you could write your own code change for that.
Okay, great. Thank you for your expertise in all of those questions. As I mentioned at the beginning, this Hangout was recorded and we'll make the recording available on our website after processing. I'll also send an email to everyone who registered with that link. If you'd like what you heard today and want to start exploring Terraform, I encourage you to check out our Learn site. You can find it at learn.hashicorp.com/Terraform. Hope you all enjoyed today's Hangout, have a better understanding of Terraform. Thanks for hanging out with us today, and a big thank you to Kevin for his time. This wraps things up for us. Have a great rest of your day. Bye.
Thank you.